Hello lovelies, this video is a shorter version of my whole of GCSE maths with just the foundation bits in to make it easier for foundation students to revise and to not get distracted by all of the other bits that are in the big long 2-hour video, because we don't want to do a 2-hour video. The other things I have to help you are the predicted papers, which are over on my website. You can go and download those straight away. And we've got workshops and free flashcards and a free course. Loads and loads of things to really help you get that grade in your GCSE math. If in the exam they ask you to write it as an integer, the answer is an integer, they are looking for whole numbers. Do not be afraid in the exam to draw out number lines. It is just you and the examiner. So you are never going to be embarrassed. Your friends are never going to know if you draw out a number line in the exam if you need to for a question. So for positive and negative numbers, especially negative numbers, loads of people have problems ordering these. Just draw a number line, take your time and fill it in slowly. To make your life easier in the exam, I strongly suggest that you get familiar with fractions. It is really going to help you if you know your fraction to decimal conversions, that you are used to putting these in order. You can make flashcards, you can watch a video that I've made doing flashcards, or you can go to my website to save a bit of time and download those from there. But this is definitely something you should spend time in, because on the non-calculator paper this is going to come up and it will make your life a lot easier if you are familiar with this. You need to be able to use a lot of symbols in GCSE maths. Equals, not equal, less than, more than, less than or equal to, more than or equal to. If they ask you in the exam for a mathematical operation, what they mean is divide, add, subtract or multiply something. And in the exam you're going to be doing this a lot. In your non-calculator paper it is going to come up a lot, so I strongly suggest that you learn your long division and your long multiplication. And for the calculator paper, you know how to use your calculator properly, including BIDMAS. This is really important. When we are adding fractions, we need to make the bits on the bottom the same. So we need to make the denominators the same. So I'm just going to take this one here, times it by 2, giving us 2 over 6 plus 1 over 6 equals 3 over 6. For subtracting fractions, again, we need to make the number on the bottom, the denominator the same. So I'm just going to times this one. No, I'm not going to times this one by 3, giving us 3 over 6 minus 1 over 6, which equals 3 minus 1, 2 over 6. We can then divide that by 2, giving us 1 over 3 as our simplified answer. When we're multiplying fractions, we deal with the top bit and then we deal with the bottom bit. So we have 1 times 2 over 5 times 3, which gives us 2 over 15. If we are dividing fractions, the easiest thing to do is just turn one of them upside down. So we get 1 over 2 times 6 over 1, which, just like times in fractions, is 1 times 6 times 2 times 1, which gives us 6 over 2. 6 divided by 2 equals 3. When we are adding decimals, it is important that we keep things consistent, so fill in any spaces with any blanks, and then we are just going to go down as normal. So 0 plus 8 is 8, 3 plus 1 is 4, 2 plus 9 is 11, so we carry 1, 9 plus 5 plus 1 is 15, so we carry 1, and then 1 plus 1 is 2. Sticking with the same number again, I'm going to pop my number in there, and we can see that 0 minus 8 isn't useful, so I'm going to do 30 minus 18. 30 minus 18 equals 12, that goes in there. 2 minus 9 isn't helpful, so I'm going to borrow a number from here. That is going to make that one there 8, that's going to make that 12. So 12 minus 9 equals 3. 3 goes there. Then I'm going to do 8 minus 5. 8 minus 5 equals 3. And then finally 1 minus 0 gives us 1. When we are dividing decimals, the first thing we want to do is to get rid of the decimals. So we can move the decimal place 1, and if we move the decimal place 1 in one, we have to move it in the other, which gives us 72 divided by 4, which is a much nicer sum to do. So 4 goes into 7 once, and we have a remainder of 3. 4 goes into 32 8 times. So 7.2 divided by 0.4 is 18. We can do something similar when multiplying decimals. So we're just going to shift our decimal place over 1. So what we end up with is 3 times 15. 3 times 15 is 45. And because we moved our decimal place once in the other direction, we have to move it twice in the other direction. Once for moving it this way, once for moving it this way, so it has to move 2 times back, giving us an answer of 0.45. At the beginning of the calculator paper, they might ask you to put some numbers into a calculator. Just check you're doing it correctly, and if they don't let you do it on the calculator paper, if it's on the non-calculator paper, you need to be using BIDMAS or BODMAS, whichever way you prefer it. Brackets, indices or orders, division, multiplication, addition, and subtraction. Add and minus are opposite operations, and divide and times are opposite operations. So if we have x plus 4 to get x on its own, we need to do the opposite, we need to minus 4. If we have x minus 10 and we want to get rid of the minus 10, we need to do the opposite and add 10. If we have x over 3 and we want to get rid of it, we need to do the opposite and times by 3. If we have 4x and want to get rid of 4, we need to do the opposite and divide by 4. Prime numbers are numbers that are only divisible by themselves and 1, and it's really helpful just to recall the first few prime numbers. So if a question comes up in the exam, you don't have to work them out. The first few are 2, 3, 5, 7, 11, 17, and 19. When we are looking for factors, it is numbers that other numbers can be divided by. So 20 is divisible by 1 and 20, by 2 and by 10, and 4 and 5. For multiples, we're going upwards, so 40 and 60 are both a multiple of 20. The highest common factor for a number is a number that is a factor of both things, and it's the highest one. So you need to look at the two numbers you're comparing, work out all the factors. So factors of 9 are 1 and 9, 3 and 3. Factors of 12 are 1 and 12, 4 and 3, and 2 and 6. The highest number that is common to both of these is 3. The lowest common multiple is something that's a multiple of both numbers, but is the lowest common multiple of both numbers. So if we look at our 8 times table and our 12 times table, we have 8, 16, 24 and 32, and our 12 times table, 12, 24, 36 and 48, and we can see that the lowest number that is on both of those lists is 24. For prime factorisation, we need to take everything down to our prime numbers. But remember, our prime numbers are things that can only be divided by themselves and 1. So 2 and 24, we can go into 2 again, that is 2 and 12. We can go into 2 again, that is 2 and 6. We can go into 2 again, that is 2 and 3. So these are our prime factors. That gives us 2 times 2 times 2 times 2 times 3, or 2 to the 4 times 3. It is well worth learning your square numbers, definitely 1 to 13, 15 and 20, your cube numbers if you can as well, because they come up so often. It's really, really important that you know these. Here is my little video I've made on these. You can make your own flashcards. I strongly recommend making flashcards. Or if you want to save a bit of time, going at my flashcards from my website. So square numbers. So here are your square numbers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 15 squared, and 20 squared. Really, really worth learning those. You need as many cube numbers as you can, but I definitely recommend the first 5. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. And if you know your square numbers and your cube numbers, you are going to be able to identify your square and cubed root. Of many of these, as you can remember, is really going to help you on the non-calculator paper and is massively going to speed things up. And if you recognise these numbers as important numbers, then that's definitely going to give you a hint as to what to do on some of the other more complicated questions. It is really important that you can use your calculator properly to calculate powers of 4 or higher and calculate roots, square roots, cubed roots, roots to the 4, roots to the 5. This is really important, so just spend some time getting familiar with your calculator, learning which buttons to press in which order, so when you go into the exam you know what to do. And again, please spend some time with your calculator, getting to know how to properly use the fractions button, the little keypad in the middle, and getting to know how to use the shift key and where pi is. Sometimes long numbers are a little bit of a hassle to write out, so we write them in standard form. Now what we need to do with standard form is take our decimal place from there and move it to there. So we are going to get 2.7 times 10, and then we need to work out how many places our decimal place has moved. 1, 2, 3, 4, 5, 6, 7. So that very long number there can be written as 2.7 times 10 to the 7. Works in a similar way for numbers less than 0. We need to move our decimal place from here to here. So I'm just going to pop it in there. We are going to get 3.92 times 10, and because it's less than 0 it is minus, and then we count the jumps. 1, 2, 3, 4, 5, 6, 7, 8. 3.92 times 10 to the 8. Much easier to say and write than this number here. If we're going the other way round, 4.3 times 10 to the 4, so 3, 4, 3, and then after decimal places we need 4 digits. So this is our first one here, 1, 2, 3, 4. We can check this because our decimal place has moved from here to here, so that should be 4 jumps. 1, 2, 3, 4 jumps. With numbers below 0 it works a very similar way, so here we have minus 6. The first thing we can do is write out 6 zeros. 1, 2, 3, 4, 5, 6. Put our decimal place in, put our numbers in, 9, 2, 1. And you'll notice our decimal place has moved from here to here, so we can check the jumps and it should be 6, 1, 2, 3, 4, 5, 6. This is another one where it helps to be familiar with the buttons on your calculator and how they work, just in case you have to input this in during your exam. It is really going to help you in the exam if you know your fractions to decimal and your decimal to fractions conversions. It is really worth taking the time to learn these. You can go and watch a video I've made about this, make your own flashcards, or if you want to save a bit of time, pop over to my website and you can download flashcards from there. As well as using whole numbers in ratios, you need to be able to use fractions in ratios as well. On the non-calculator paper, they are likely to get you to use some fractions, so you need to be able to work out what fractions are. So 10% of 800 is going to be 80, 15% is going to be 80 plus half, so that is 120, whereas 200% is going to be double it. Units conversions are incredibly important. You need to be able to recognise when to convert units, so everything needs to be in the same units, and you need to be able to do that confidently. So grams into kilograms, there are 1,000 grams in a kilogram, so for this one we need to divide by 1,000, and if we are going the other way we need to times by 1,000. If we are going from seconds into minutes, we need to divide by 60. Minutes into hours, we need to divide by 60. Hours into minutes, times by 60. Minutes into seconds, times by 60. For millimetres into centimetres, we need to divide by 10. Centimetres into metres, it is divided by 100. Metres into kilometres, it is divided by 1,000. Kilometres into metres, times by 1,000. Metres into centimetres, times by 100. Centimetres into millimetres, times by 10. To go from pence into pounds, we need to divide by 100. To go from pounds into pence, we need to times by 100. Sometimes when we have numbers that go to a large number of decimals, it's annoying to work with, especially on the non-calculator paper. So we can use estimation. So 3.9412 can be rounded up to make 4, and 3.0001 can be rounded down to make 3, which is a much easier sum for us to do. You might be asked whether your answer is an overestimation or an underestimation. If you're rounded up, it's going to be an overestimation, rounded down, underestimation. But if it's in a fraction, it's slightly different. So if you've rounded up and you made it the denominator, it is then going to be an underestimation. Rounding is an important skill. So here are two numbers. We are going to round to 2 and 3 significant figures. So the first thing you need to do is to look where your decimal places or where your significant figure is going to be. So for 2 significant figures, we want these two. We then need to look at this number here. Because it is above 5 to 2 significant figures, this is going to be 9, 4, and then we need to replace the rest of the numbers with 0. So 9 becomes 0, 2 becomes 0, 1 becomes 0, 3 becomes 0, 2 becomes 0, and 1 becomes 0. For 3 significant figures, these are 3 numbers we're going to write down. So 9, 3, 9. We then need to look at this number is below 5, so we don't need to round it, but we do need to write them in place as zeros. So 2, 1, 3, 2, 1. The same for decimal places. We are going to be going first to 2 decimal places, so that is these ones. Looking at this number here, it is below 5, so it's going to be 9.39, and because it's below 0, we don't actually have to pay attention to the rest of them. Looking at 3 decimal places, it is these ones. Looking at this number here, we're going to get 9.392. Here we have an inequality, and our number x falls between these two numbers. So it is greater than or equal to -5, and we can draw that on a number line by putting in a filled in circle, or less than 4. So that is an open circle, and our inequality will fall in this region here. When we're talking about the limits of accuracy, we're talking about combining rounding and, in this case, inequalities. So what is the lowest possible value that could round to -5? So if we have a think about this, -5.1 to one significant figure is going to be -5. So is -5.3 and -5.4, but -5.5 is going to round to -6. So our lowest possible value is -5.5. Our highest possible value that is rounds to less than 4 but not equal to 4, and this is something that's a little bit complicated, is going to be 3.4. Because if it was 3.5, that would round to 4, but our number is not equal to 4, it is less than 4. So these are our limits of accuracy. Sometimes in maths, writing things out fully can be really, really tedious. So there are a few conventions that we use to speed things up. You have to be able to recognise what they mean, and you have to be able to use them in algebra. So x times y can be written as xy. We don't need to bother writing the times in. If we have x and x and x, again, that's writing out quite a lot of things. We just have 3 x's. X times x, we can write as x squared, and then if we want to have x divided by y, we can just write that as x over y. You need to be able to put terms into an algebraic expression. So here we have 2x plus 3 and x equals 4. So what we need to do is replace the x with 4, so that is 2 times 4 plus 3 equals 8 plus 3 gives us 11. You need to be able to collect like terms in an algebraic expression, and for this what I suggest you do is either rewrite things in order or get your highlighters out and start highlighting. So we have x's, things with x in, things with x in, things with y in, things with y in, things with y in. Now we can rewrite this as x plus 2x plus 3x. Altogether that makes 6x plus 1, 2, 3y's. I can multiply out a number in front of our bracket, so here is our 2 in front of our bracket. We need to times it by everything inside the bracket to get rid of the brackets. So we have 2 times x gives us 2x plus 2 times 4 gives us 8. Whenever you see a long, complicated algebraic expression, this one's quite simple, but you should always consider factorising it. To factorise it, you need to look at what both things have in common. So both the 3y and the 12 can be divided by 3, so we're going to put that outside. We're going to make some brackets. 3y divided by 3 is y. 12 divided by 3 is 4. I can multiply out 2 expressions. Now this is where things start to get a bit complicated, and I think it's really important that you draw your lines in, even if you are like really good at this. Please just draw your lines in, because in the exam you might get a little bit stressed, you might make a silly mistake that you wouldn't otherwise make. So please draw your lines in. There are 2 different ways of drawing your lines in. You can go 1, 2, 1, 2, or the way that I prefer to do it, just because it looks a little bit nicer, is like this, and then we can turn it into a smiley face. Now I know this is really trivial, but exams are stressful situations, so anything we can do to make it a little bit nicer, a little bit happier, a little bit less stressful is going to be a good thing. So there is my expression, and you can do this in whatever colour you like. We still have to multiply it out. The other thing I would like you to do is once you have finished doing a line, just cross it out so that you know you've done it, you don't repeat it. So first of all, I'm going to do this line here. That gives us x squared, and I'm going to cross out the line because I know that I've done it. Then I'm going to do this line here, 3 times 4. Then I'm going to cross out the line so that I know that I've done it. Then I'm going to do this one, 3 times x. Then I'm going to cross out the line so I know that I've done it. Then I'm going to do this one, x times 4. Then I'm going to cross out the line because I've done that one. Then you need to collect the terms together. So these two, those two are the same, so we're going to need to put them together. And you need to sort things into the right order. So x squared plus 7x plus 12. Now, there are 2 different methods up here. This one will give you things in the right order, whereas the smiley face method won't give you things in the right order. You just need to remember to put them in the right order. Factorising things that were in the form of x squared plus bx plus c. So for this one here, we need 2 numbers that multiply. And for this number here, we need 2 numbers that add. So first thing you do is you write down your 2 open brackets. Since this is just x squared, we can pop that in already, x. Since both of these are plus, we can pop that in as well. Then we need to think of all the things that multiply to make 8. So we can have 1 and 8. We can have 2 and 4. I think that is everything. Now you need to look at your list of numbers. Can we use 1 and 8 in any way at all to make 6? No, we can't. Can we use 2 and 4 in any way at all to make 6? Yes, we can. 2 and 4. Sometimes your algebraic terms will be getting quite complicated, so you want to make things as simple as possible. And when simplifying an algebraic expression, you're going to need to collect like terms, you're going to need to factorise, you might need to deal with some brackets, expanding brackets in there. You also might have to deal with some fractions or some surds. Rearranging equations to make a different thing subject to the formula comes up so frequently and in so many different places. It's definitely one of the core skills I recommend you practice a lot. So here we are going to make y the subject of the formula. So first thing I'm going to do is to minus 6 from both sides. So we're going to get 8x plus 4 minus 6 plus 4 minus 6 is going to give us 8x minus 2 equals 2y. You can see y is currently times by 2, so I'm going to divide that by 2, giving us 8x minus 2 divided by 2 equals 2y divided by 2. You can see here I've got a 2 on top and the bottom, so that's going to cancel. Here I've got numbers I can divide, so that is going to give me 4x minus 1 equals y. It does not matter that y is on this side of the equation. It's exactly the same as having it on this side, it just happens to be on the right hand side. Do not feel you have to minus 2y at any point to get y over here, and then minus 8x to get x over this side. It's perfectly okay to have y on the right hand side. Surds are another example where knowing your square numbers and your square root especially is going to come in really, really handy. And surds are not scary, they're just a nice, easy, simple way of writing a long, horrible number. For example, square root 6 is much easier and more accurate than writing the number out in full, but you can just treat them like anything else in algebra. 2 square root 6 plus 2 square root 6, all we need to do is to add the numbers in front, just like adding 2x and 2x, and we're going to get 4 square root 6. Again, just like algebra, if you have 6 square root 6 divided by 2 square root 6, 6 divided by 2 is going to give us 3 square root 6. If we have square root of 2 times square root of 18, that is exactly the same as saying square root of 2 times 18. 2 times 18 is 36. The square root of 36 is 6. So I know they look awful, but they're really, really not, I promise. If we are multiplying terms, we need to add the indices. For example, x cubed times x to the 7, we need to add the indices, so 3 times 7 will give us x to the 10. If we are dividing terms, you need to subtract the indices. For example, x to the 6 divided by x to the 2, 6 minus 2 is 4, so it's going to give us x to the 4. Functions are another thing that look awful and scary but really aren't. So fx equals 3x plus 2, we need to answer if f is 3. So all you need to do, you'll notice here that x has been replaced by 3, so in here we need to replace x with 3. So that is going to give us 3 times 3 plus 2, 3 times 3 is 9, plus 2 equals 11. Coordinates are going to be in the format x and then y, so x and then y, and vectors not relevant here but kind of, so x on top and y on the bottom. So if you're plotting points, we need to go x first, so 2 across and then 4 up. So our first coordinate will be there, and we mark that with a nice cross with a sharp pencil. A blunt pencil is not going to do you any good in the exam. For our second set of coordinates, we go -1, -3, down there. Again, sharp pencil. If you are plotting a line from an expression, say y equals 2x plus 1, the simplest thing you can do is work out some points. So when x equals 1, y equals 2x plus 1. So when x equals 1, y equals 2 times 1, which is 2 plus 1, making that 3. When x equals 2, we have 2 times 4, 2 times 2, which is 4, plus 1, giving us 5. When x equals 3, it is 2 times 3, 6 plus 1, 7. We can now plot those points on our grid, and using a ruler, which I don't have, you can join the points up. When we're trying to find the gradient or the intercept of a straight line, we need to be thinking y equals mx plus c. M being the gradient and c being the intercept. So if we look at finding the gradient first, what you need to do with a pencil and a ruler is draw the biggest triangle that you can fit on. Bigger triangles are better because they are more accurate. So I'm going to go to there because it's a nice number. So we are going from 5 to -3, that gives us 8. Then we are going from 3 to -1, that gives us 4. So to find the gradient, it is up divided by across. So up we went 8, across we went 4. So 8 divided by 4 gives us a gradient of 2. And then c is just where it crosses the y-axis. It crosses the y-axis at -1. So our c is -1, giving us a total equation of y equals m, which is 2x, c, which is -1. If two lines in the format y equals mx plus c are parallel, they are going to have the same gradient, so the same m. So it doesn't matter where they cross the y line, if they have the same gradient, they will be parallel. For a quadratic graph, the roots are going to equal the x-intercept, and the x-intercept are going to be these points here. on the x-axis. Turning point is going to be the coordinates of this point here. The graph for y equals x is going to go straight through the middle. Increasing a number in front of the x is going to make it steeper. Decreasing the number in front of the x is going to make it shallower. Putting a number after it is going to shift it either up or down. You need to recognise the shape of the graph for x squared, which is nicely like a big smiley face. Unfortunately, minus x squared is like a sad face. Putting a larger number in front of the x squared, say 2x squared, squashes it. And a smaller number makes it expand outwards. X plus a value squared is going to shift it left by that value. X squared plus 3 is going to shift it up by that value. Here is the graph of y equals x cubed minus x cubed, 3x cubed with a large number in front of the x cubed, a third x cubed with a small number in front of the x cubed. X cubed plus a number will shift it up or down by that number, and x plus a number and then cubes will shift it left or right by that number. Here is the graph for 1 over x. The important things to remember when you are plotting a graph is that your points are accurate. A sharp pencil and a cross is the best way to accurately plot points. That they are clear, that you do not do a massive circle or a massive splodge, or your pencil's not sharp enough so it's not exactly clear to the examiner whether you've plotted it on one box or another box. Your axis has had a clear scale on it. The scale has to be in order, the scale has to make sense, it has to have a title, and it has to have units. And your line needs to be a smooth, curved line. This sort of line here is not going to get you any marks in the exam. Remember, this is maths, not arts. We need a smooth, strong, confident line and a line of best fit. Distance time and velocity time graphs look identical. The only difference is that one is labelled distance and one is labelled velocity or speed. And you have to be paying attention to the graph before you can answer the question, because even though they look the same, they're telling you very, very different things. So if we first look at this section here, on a distance time graph, this is going at a steady speed. The middle section here on a distance time graph, you'll see that as time is progressing, distance is not progressing, so this is staying still. Then the last section, they are also moving at a steady speed. But if we look at the slope or the gradient of the line, you'll see that this steady speed is slower than this steady speed here. If we look at a velocity time graph, the first part is acceleration. The middle part, where it's flat, so time is going across, velocity is not increasing, but velocity is not zero, so they are still moving. So this is now a steady speed. And then the last part is again acceleration. But if we again look at the slopes, you'll see the slope here is shallower, the gradient is shallower than this one. So it is accelerating less rapidly. If we want to solve two linear simultaneous equations from a graph, we need to be drawing the points on the graph, we need to be looking at where they cross over, and that is going to be the solution. If you have a linear and a quadratic equation, again, you need to draw them on the graph, and the points where they cross over, this is going to give you two solutions, is the answer. Here we have a quadratic equation that we need to solve by factorising. So we need to draw our brackets, x. You can see we have a plus and a minus, so they're not both pluses, we can't write that in at the moment. We need to look at numbers that multiply to make 4, and then add or subtract to make 3. So we can have 1 and 4, or we can have 2 and 2. But it's a bit more complicated than that because it's minus 4. So we can have minus 1 and plus 4, or we can have plus 1 and minus 4, minus 2 and plus 2. But they need to add in some way together to make 3. There's nothing we can do with 2 and 2, so we can't do that. It has to be plus 3, so minus 4, plus 1 is going to give us minus 3, so it's not that one. So it has to be this one here. So we are going to have plus 4 and minus 1. I've lost my brackets. Plus 4 and minus 1. Now we know this equals 0. Now if something to equal 0, two things times by each other to equal 0, one of these has to equal 0. So to make each bracket equal 0, x plus 4 equals 0. We need to rearrange that. So x is minus 4, or x minus 1 equals 0, which rearrange will give us x equals 1. So there are two solutions to a quadratic equation. By factorising, you have to put it into brackets and then make the brackets equal 0. Simultaneous equations can be solved in a large number of different ways. You need to find the way that works for you best, which you prefer, and then go with that one. Substitution, which is for no particular reason my preferred method, multiplication, addition, subtraction, or you can solve them graphically. Graphically it's a bit more complicated, and unless they ask you to do it, don't generally do it that way. So I'm going to show you two different ways of solving the same equation, and hopefully we should come up with the same answer both. I'm going to call this equation number 1, I'm going to call this equation number 2, and I'm going to start with substitution. So I'm going to rearrange equation number 1 to make y the subject of the formula. So 2x plus y equals 7. Y equals 7 minus 2x. So now I know what y is, I can pop it into equation number 2. So 3x minus y equals 8. 3x minus y, which we know from previously, is 7 minus 2x equals 8. Multiply out the brackets. 3x minus 7 plus 2x equals 8. Tidy this up, so 3x plus 2x gives us 5x, 8 plus 7 gives us 15. 15 divided by 5, x equals 3. Now we know what x is, we can put that into either equation number 1 or equation number 2. I'm just going to pick equation number 1. 2x plus y equals 7. X equals 3, so 6 plus y equals 7. Rearrange that, so y equals 1. So that's doing it by substitution. I'm now going to do it by addition. Now addition, subtraction and multiplication all go together, because if you want to have addition, you need to have something with the same number in front. So here I've got 1 and 1 in front of y, but different symbols. So if I add these together, they're going to cancel each other out. Subtraction would work if this was plus y and plus y. And if we didn't have any of the numbers the same here, we could multiply one of these equations. For example, we could multiply this one by 1.5 if we wanted to get x the same, so we could either add or subtract those. So those three work together. So I'm going to add the equations together. So 2x plus y equals 7. 3x minus y equals 8. Add them together gives me 5x minus y plus y gives me 0. 5x equals 15. Divide that out, x equals 3. Now that I know that x equals 3, I can pick either of the equations. Since I picked equation number 1 last time, I'm going to pick equation number 2 this time. So 3x minus y equals 8. X equals 3, so that's 9 minus y equals 8. Take 9 over to the other side, so we get minus y equals minus 1. Times that by minus 1, y equals 1. So you can see both methods give the correct answer. Both methods are valid. You just need to pick which method you prefer. The next part, in equations from a situation given in a text, can be tricky for some. Primrose went to the shop and she bought 4 biscuits and 1 sweet. This cost her $1.24. The next day she went to the shop again and bought 2 biscuits and 2 sweets. This time it cost her $1.99. How much does each sweet and biscuit cost? Now, on the face of it, this may look like it may look like an impossible question, but what I've done is I've taken the information as a text, I've written it down as 2 equations, and now I can solve it as a simple simultaneous equations question. Don't try and solve this, I literally just made it up, so I don't know whether there are actual answers to this, so please don't leave loads of comments about how I've done the equation wrong. Solving inequalities can scare people because of this big inequality here in the middle. But you can just treat it exactly the same way as you can an equals. So x plus 3 is greater than 7. Moving the 3 over to the other side, minusing 3 gives us x is greater than 4. Now we need to pop that on a number line. So we can draw an open circle at 4, because open circle shows that it's greater than, if it was greater than or equal to. If it had this symbol, we would do filled in circle, but it's just greater than. And then we are going to go this way. Now, there are a few things you need to be aware of when you're solving inequalities. The sign does not change direction if you add or subtract numbers or if you divide by a positive value, but the sign will swap, so from greater than to less than, if you divide or multiply by a negative value. If you are given an nth sequence, say n plus 4, you need to be able to find any sequence in this term. So when n is 6, n plus 4 is going to equal 10, and when n is 100, it is going to equal 104. Now, slightly more complicated than that is doing it reverse, finding the nth term from a sequence. The first thing you need to do is to work out the differences. So between 1 and 5, it is plus 4. Between 5 and 9, it is plus 4. And between 9 and 13, it is plus 4. Telling us the first part is going to be 4n. Now we can actually work out what 4n is. So if n would equal 1, 4n would equal 4. If n was 2 for the second term, 4n would be 8. If n was 3, 4n would be 12. If n was 4, 4n would be 16. Now we can work out the difference between what the term would be if it was 4n. So this is 4n. And now we're going to work out the difference. So 4 minus 1 is 3, 8 minus 5 is 3, 12 minus 9 is 3, 16 minus 13 is 3. That gives us the second part, which is minus 3. 4n minus 3. Your square numbers, cube numbers and triangular numbers are going to come up a lot. So it is worth recognising them at least, but preferably what I would like you to do is try and learn as many as you can. For your square numbers, that is 1 to 13, 15 and 20. So 1 to 13, 15 and 20. They will speed things up if you can recognise those, as many cube numbers as you can and as many triangular numbers as you can. You can see over here that I've made you a video going through all of these. Flashcards are a great thing to do, or you can go to my website and download the ready-made set of flashcards to speed things up. To get from seconds to minutes, there are 60 seconds in a minute, so you need to divide that by 60. To get from minutes into hours, there are 60 minutes in an hour, so you need to divide that by 60. To go the other way, to go from hours into minutes, you need to times by 60, and then minutes into seconds times by 60. Grams into kilograms, you need to divide by 1,000. Kilograms into tons, divide by 1,000. Tons into kilograms, times by 1,000. Kilograms into grams, times by 1,000. Now, meters per second into kilometers per hour is a little bit tricky. We need to do several steps. The first step is times by 60. The second step is times by 60. And then the final step, divide by 1,000. And then in reverse, if we want to go from kilometers per hour to meters per second, it is times by 1,000, divide by 60, divide by 60. If we want to go from pence into pounds, there are 100 pence in a pound, so we need to divide by 100. To go the other way, we need to times by 100, and it is the same for prices. 1 gram per centimetre cubed is equal to 1,000 kilograms per metres cubed. So slightly different here. We need to times that by 1,000, and then going the other way, we need to divide by 1,000. There are 1,000 pascals in a kilopascal. So to get from pascals to kilopascals, notice how the other one was unusual. We need to divide by 1,000, and this one we need to times by 1,000. To go from centimetres into metres, there are 100 centimetres in a metre. So we need to divide that by 100. Going the other way, we need to times by 100. Now, as we go from length to area to volume, it gets a bit more complicated because in 1 metre we have 100 centimetres, 1 metre, 100 centimetres, 1 metre, 100 centimetres. So 1 metre squared is not equal or is not the same as thinking about going from centimetres to metres, because we have 100 times 100, which is 10,000 centimetres squared. So to go from centimetres squared into metres squared, we need to divide by 10,000. Metres squared into centimetres squared is times by 10,000. We can think about cubed in the same way, because 1 metre cubed is 1 metre by 1 metre by 1 metre, so 1 metre is 100 centimetres, 1 metre, 100 centimetres, 1 metre, 100 centimetres, so 1 metre cubed is going to have 1, 2, 3, 4, 5, 6 zeros after it. 1, 2, 3, 4, 5, 6 centimetres cubed after it. So this is a bit more complicated. Going from centimetres cubed into metres cubed, we need to divide by 10 million. 3, 4, 5, 6, and then going the other way, times 2, 3, 4, 5, 6. To be able to use scale factors, scale diagrams and maps, you're going to need to get your ruler out, so please remember to take it into the exam with you, and you're going to need to measure really accurately. I'm talking millimetre measuring here. And for every, for example, 1 centimetre you measure on the map, that could be 3.7 kilometres in real life. So you just take whatever you can measure on the map, on the exam paper, and times that by the scale factor given to you in the exam. Ratios can come up in a lot of different ways. One of the ways they can come up is in particularly wordy questions where it doesn't necessarily look like a ratios question, but you have to work out and you have to take the real life context and express the relationship as a ratio. So at a party there are men and there are women. There are 8 men for every 6 women. If there are 24 women, how many men are there? Now you'll notice when I've written this out, I've left a big gap in the middle here. That is because I'm going to put 1 in here, and this is how I'm going to work out my ratio. So what do I have to do to 6 to get down to 1? I have to divide that by 6, so I have to do the same to the other side. Divide that by 6, which is going to give me 4 over 3. Now I need to get from 1 to 24. To get from 1 to 24, I need to times that by 24, so I need to do the same over the other side. Times by 24, so 4 over 3 times 24 equals 32. And there are lots of different ways you can do this. You can see this one has included a fraction. You could also be asked to work out parts, so you just need to work out the total number of parts, in this case which would just be 8 plus 6. Percentages can come up on the calculator or the non-calculator paper, so it's worth knowing a couple of ways to work them out. On the non-calculator paper, you can work them out by using blocks of 10s, 5s and 1s. So 10% of 824 would be 82.4. 5% will be half of that, which would be 41.2. And then 1% of that would be 8.24. And using combinations of 10, 5s and 1s, you can generally make any number that you like. So in your calculator paper, you needed to find 32% of it. All you can do is take 32, divide that by 100, come up with the number you need to type into a calculator, which is 0.32, multiply that by 824, and you can get your answer like that. Interest is just another way or another word for working out percentages. So if you leave your money in your bank, the bank will pay you interest on it. Unfortunately, not very much interest at the moment. It's going to be, say, 3% interest on £824. How much would you get after a year? If we have questions or equations using direct or inverse proportionality, for direct proportionality, we can say that x is equal to y, but we need to put a constant in there, which is generally k. You can take any values that are given to you in the question, plug that in, find the value of k, and then further use the value of k in any other questions. For things that are inversely proportional, we can say that x is equal to k over y. Again, pop any values in, work out the value of k, and then you can go on and use that value of k to finish off the question. When things are directly proportional, you are going to get a nice straight line graph. When things are inversely proportional, you are going to get a curved graph. When you have a graph, the gradient of the graph is going to show you how quickly things are changing, or the rate of change. The example I've used here is a distance time graph, and speed, the rate of change, is going to be distance divided by time. So our gradient is always going to be the change in up divided by the change in across. There are two ways you can work out interest: the long, slow and methodical way, or you can remember the equation. So the long, slow and methodical way is to work out each year by year by year. So if we start with £795 at 3.5% compound interest, at the end of year one they're going to have £795 plus the interest which is accrued, which is going to be 27.825, which is 3.5% of 795, so that's going to equal 822,825 in total. That is the number you then use for the start of next year. Work out 3.5% of 822, which is going to be 2879. And this is where your numbers start getting quite long. So you need to round them, or you need to store them in your memory calculator. But don't round them too short, otherwise you're going to get a rounding error, which is going to end up in you having the wrong answer. So either write your entire number down from the calculator, or store it in your calculator's memory. So after 3 years we're going to have £881.43. Now the equation that you can remember for this is the final amount is equal to P, open brackets, 1 plus R over 100, close brackets, to the power of N, where P is the amount that you start with, R is the interest rate, and N is the number of times you've accrued interest, which generally is going to be year by year. So popping that in here, we can see that our start amount was 795. 1 plus 3.5 over 100 to the power of 3 gives us really, really nicely the same answer. One way is quicker, but you have to remember the formula. The other way is slower and is more likely to make mistakes because you have to write down the full number. And if you do it the way that the examiners don't want you to do it, for example, if they want you to use this formula and you do it by year, you might lose your working marks. So this is a tricky one you need to be careful of. Some nice definitions to start us off here. Point is going to be the point of the shape where two lines meet. A line is going to be a thing connecting two points. Vertices, that is going to be the point, or on an ellipse, your vertice is going to be the point of steepest angle. An edge, again, is along here, and then a plane is going to be a flat surface that goes in all directions. Here we have some parallel lines, here we have some perpendicular lines, and a right angle can be indicated if we just draw a little box in the corner there. Parallel lines can be shown by little arrows going like this, and if we look at our equation for a straight line, parallel lines are going to have the same gradient, so m is going to be the same on both of them. For a regular polygon, we're going to have all sides being the same and all angles being the same. And if n is our number of sides, we can find the sum of the interior angles by doing n minus 2 times 180. This applies whether it is a square or a regular pentagon, regular hexagon, whether hexagon, octagon, nonagon, etc., etc. When we reflect something, we can flip it or reflect it across a line, creating a mirror image. Rotational symmetry is when something looks the same as it did at the beginning after you've turned it round a little bit. If you want to draw a perpendicular bisect of a line, you need to open your compass. You need to open your compass really wide. And we're going to start by putting a point of our compass on A over here. And what you need to do is draw a big circle. So a big arc that goes around like this. Switch your compass point so it's over on B. Again, draw a big arc from B. And then this point and this point here are the points that are important. You need to join these two up with a pencil and a ruler, a sharp pencil, a ruler and a compass. Obviously I know I'm not doing that, but you need to do that in your exam. and then this line here is going to be your perpendicular bisect. For loci problems, you may be given a scale that you have to use, so you're going to need to set your compass and your ruler to that scale, or you may not be given one. What you're generally going to be asked to do is to draw a circle around point A with a compass, not roughly like I'm doing, and then a circle around point B, again with a compass, not like I'm doing, and see where those two intersect. But the really, really important thing here is accuracy with compasses, accuracy with rulers. So if your ruler at the moment is covered in Tipp-Ex, is broken, the markings have come off it, please, please, please go and spend 50p, a pound, getting yourself a decent, clear ruler. Or if you can't do that, go and talk to your head of year or your form tutor or your maths or science teacher, and they will generally be able to help you. If we have angles that all meet at a point, A plus B plus C plus D are going to equal 360. If they are on a straight line, A plus B is going to equal 180. If we have vertically opposite angles, they are equal. When we have parallel lines, our corresponding angles are equal. Don't forget, this is also going to have alternate angles, and they are also going to be equal. And it is going to have alternate angles. Now, the example does not like you calling these Z angles, but they are also going to be equal. So if we could use the terms corresponding angles and parallel lines, alternate angles and parallel lines, vertically opposite angles, just don't call them by colloquial terms like Z angles. And all the angles inside a triangle add up to 180 degrees. A square is a regular quadrilateral. It's going to have equal sides, it's going to have equal angles, these are 90 degrees. These are right angles. Its area is the two sides multiplied, so that's going to be x squared for this. The perimeter is 4x, and the length of the diagonal is just going to be x times the square root of 2. A rectangle is going to have two sets of equal sides, so this is going to be equal, and these are going to be equal. But the angles inside are going to be equal, and again, they are going to be right angles. Its area is one side times the other side, so length times width, and its parameter is 2x plus 2y. A parallelogram is like a slightly skew-width triangle or rectangle. For the parameter, we need to go all the way around the edge, so that is 2x plus 2y. For the area, we need the base times the height. It is going to have two sets of lines that are the same. The opposite angles are going to be equal, and angles A and angles B are going to add up to 180. For a trapezium, we're going to have four random sides. For the perimeter, it's A plus B plus C plus D, so going all the way around the edge. The area is half the top, the bottom times the height, and then the top and the bottom are just going to be parallel. For a kite, we're going to have two sets of lines that are the same. So our perimeter is going to be 2x plus 2y. Our area is going to be half A plus B, so that's the height times the width, and we're going to have one set of angles that are the same. For a rhombus, you're going to have all sides being the same, so the perimeter is going to be 4x. The area is going to be half A times B, and opposite angles are going to be the same. If you want to prove that two triangles are the same, you need three pieces of evidence, and there are four different ways you can get three pieces of evidence. Side, 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 angle, angle, or right angle, hypotenuse, side. So these two triangles, even though they're drawn in different orientations, have three sides that are the same, so they are the same. For side, angle, side, the angle has to be the angle in between the two sides. So here we go, side, angle, side, angle, side, they are the same. Here we have two triangles that have two identical angles and a side that are the same, so these are the same. Our last two triangles both have a right angle, they both have the same hypotenuse, and one of the other sides is the same. For an equilateral triangle, we are going to have all sides and all angles being the same. For an isosceles triangles, we are going to have two sides being the same, and then the angles at the base are going to be the same. If you want to rotate a shape, the examiners may either tell you what to do or they may have rotated the shape and ask you what to do. You need to give the degree that it's rotated by, the direction that it's rotated by, and where it's rotated about. So we're going to rotate the shape 90 degrees clockwise, about 0, 0. And the first thing you need to do is find the first point, which for me is this point here. Rotate it 90 degrees, and then all the other points will follow on from that. If we're going to reflect a shape, they'll generally give you the line to reflect it in. Work out how far away your first point is from the line, and that will give you your second point. That will give you where your first point is the other side of the line. All your other points can reflect on from that. If you were given a translation to do, it may come as a vector. So here we need to translate by 3, 4. That means every single point has to move 3 across in X and then 4 up in Y. So we are going to end up with our shape up here somewhere. If we are going to enlarge a shape, you need to know the centre of enlargement. Draw lines from your centre of enlargement through each of your corners, and then work out the distance from your centre to your first corner. Double it, since our centre enlargement is 2, and then that will be where the corner ends up. And then your shape, drawn slightly better than mine, will end up larger and further away from your centre of enlargement. Here is the centre of our circle. The radius goes from the centre to the edge. A chord is a line that touches both edges. A diameter goes through the middle and touches both edges. Circumference is the distance all the way around. A tangent is a straight line that touches the circumference. An arc is part of the circumference. A sector is like a pie-shaped wedge of a circle. And a segment is just cutting a bit off it. When we are talking about cubes or cuboids, you need to know the faces, the edges, the surfaces, and the vertices. For a cube, it is going to be identical on all edges, which means all 6 faces are going to be identical. All 12 edges are going to be identical. It's going to have 8 vertices. If we have an edge, which is of length x, the volume is going to be x cubed, that is base times height times width, and the surface area is going to be 6 because there are going to be 1, 2, 3, then 3 behind 6 faces times x squared. A cuboid is slightly different because each of the faces are not identical. Prisms and cylinders can be thought of 3D versions of shapes that we are very familiar with in 2D. If you want to work out the surface area of these, sometimes it helps to think of these as flattened out shapes, and then it becomes a lot less intimidating, because working out the surface area of a cylinder can seem intimidating, but if you break it down into a circle and a large rectangle, well, that's not a problem at all. And to work out the volume, we need to do the surface area times the height. For pyramids, cones and spheres, the best thing you can do in the exam is to slow down and think logically about things. How many faces can you see on the pyramid? And then don't forget about the ones behind. The same for the cone and the sphere. Turning a 3D shape into a 2D shape or a 2D shape into a 3D shape can be incredibly hard to do. This is a really tricky skill. They're probably going to want you to either draw 3 elevations, so maybe top, side and front, or they're going to give you 3 and ask you to draw the 3D shape. This can be an incredibly hard skill if you are not sure about it. If you are having trouble visualizing things in 3D, or if you're just not sure about how things are supposed to look. The best thing I can suggest for you to do is to use what you have on your pencil case, the stuff that you're allowed to have in your pencil case, like your sharpener and your rubber, and try and use those to maybe try and construct some kind of 3D shape that looks similar. But this is a mental skill that you have to do in your head. It's complicated if you're not used to it. The best thing you can do is practice with this one. For maps, scale conversions, bearings, it is really important that your pencil case is up to date. So I'm talking a clear ruler that you can use that has all the divisions on it, not one that's covered in Tipp-Ex which is broken. The same with a protractor and the same with a compass. So what they could ask you to do is give you point A and point B, ask you to measure the distance between them, and say 1 centimetre is 3.5 kilometres, turn that into a conversion. They might also ask you what the bearing is, so how far around it goes from north. For that, you're going to need your protractor. You need to know and use all of these formula. Volume of a cuboid. That is length times width times height. The volume of a prism. That is the area of the cross section times the length. Pythagoras. A squared plus b squared equals c squared. Trigonometry when it's sine. That is your opposite over hypotenuse. The area of a triangle. That is half base times height. The area of a trapezium. That is half a plus b, which is the top and bottom lengths, times the height. The circumference of a circle when you have a radius. 2 times pi times radius. The area of a circle. That is pi times the radius squared. Oopsie, I'm giving it away. The area of a rectangle. Length times width. The area of a parallelogram. Good word that. Base times height. The volume of a cylinder. That is pi times the radius squared times the height. Circumference of a circle when you have the diameter. That is pi times diameter. Trigonometry when it's tan. That is opposite over adjacent. Trigonometry when it's cos. That is adjacent over hypotenuse. Speed is equal to distance over time. Density is equal to mass over volume. And pressure is equal to force over area. To work out the length of an arc, what you need to do is to work out the circumference and times that by the ratio. What I mean by that is the circumference of the whole thing, so 2 pi r. The whole thing is 360. How many degrees round was the circumference? So 2 pi r times n over 360. To work out the sector area is very similar. You need to find the area of the total circle, and then you need to times that by the ratio. So the area of the total circle is going to be pi r squared. If this is n degrees around, that is going to be pi r squared times n over 360. Remember, all the way around in a circle is 360, halfway around is 180. When we have similar shapes, the corresponding sides are going to be in the same ratio as each other, and the corresponding angles are going to be equal. For right angle triangles, you need to be thinking Pythagoras, and you need to be thinking trigonometry. So for a right angle triangle, if we have A and we have B, we can work out C by using the formula, or if we can work out one of the other sides or an angle. Now the really important thing here is labelling your angles. If we have an angle, the one opposite, labelling your sides, the one opposite is the opposite, the one next to it is the adjacent. And this is the formulas here. I'm sure there are loads and loads of brilliant ways, mnemonics that you have for remembering those. So please, please, please share them down in the comments to help other people. I strongly recommend you spend some time learning these values. They can come up in lots of different ways. To help you, I'm going to show you the video, or if you want to save a bit of time, you can get the flashcards from my website. So sine of 0 is 0, cos of 0 is 1, tan of 0 is 0, sine of 30 is a half, cos of 30 is square root of 3 over 2, tan of 30 is 1 over the square root of 3, sine 45 is 1 over the square root of 2, cos 45 is 1 over the square root of 2, tan of 45 is 1. Sine of 60 is square root of 3 over 2, cos of 60 is a half, tan of 60 is square root of 3. Sine of 90 is 1, cos of 90 is 0, and tan of 90 you don't need to know. When we are talking about vectors, it is x on top and y on the bottom. So if you want to talk about a translation, it is the movement in x and then the movement in y. If we want to add, subtract or multiply them, it's just like doing normal maths, just things are on top of each other. So if we want to add vectors A and B, first of all we look at the top line, so 1 plus 3 is going to give us 4. Then we look at the bottom, 2 plus 4 is going to give us 6. Subtracting them is the same, so 1 minus 3 is going to give us minus 2, and then 2 minus 4 is going to give us minus 2. Multiplying them works in the same way. 2 times 1 is 2, 2 times 2 is 4. In an exam, you might be given a set of raw data, and from this you might be expected to draw a graph. You might be expected to do some maths to work out the mean, median, or the mode. You might be expected to draw a slightly more complicated graph. You might be expected to draw a box plot. And this video is going to cover all of those skills. Frequency tables are one way of interpreting information, and if you're given a raw piece of information, you may be asked to put it into a table. So here's our raw information at the top: even number, odd number, and you can just start off by putting this in a tally. So 1, 1, 2, 3, 5, 5, 7, 9, 11, 11, 11, 12, 13, 18. Bar charts are another way of doing things, and what you need to be really careful with bar charts is you need to use a pencil and a ruler. You need to have your bars neatly, you need to have titles, you need to have units, you need to have a key. Pie charts are a touch more complicated to construct because we need to put everything into 360 degrees. So here we have everything out of 100. We need to work out what each degree is going to be worth. So we need to do 360 divided by 100. That gives us each is worth 3.6. We then need to take 50% strawberry times that's 50 times 3.6 is going to give us 180 degrees for strawberry. 10 times 3.6 is going to give us 36 degrees for chocolate. 40 times 3.6 is going to give us 144 degrees for both of them. You need to draw a circle. Please let it be a neat circle, not like I've drawn. And then measure 180 degrees, and remember, label things. It is really important that you label your sections. Pictograms can be used for something similar. So say we were using strawberry, chocolate or both again, and we had a key where one triangle equals 10%. Strawberry at 50% would get 5 triangles. Chocolate at 10% would only get 1, and then both at 40% would get 4 triangles. For this one, they might ask you to fill in a missing section, or to work out the key, or to work out the total. You just need to use logic and the information that you have been given. With line charts, again, for your axis, you need to have title, units, and you need to have a key. And for each point, mark on with a neat little cross with a sharp pencil where you want it to be. If you're going to be comparing two sets of data from a graph, it helps to have lines through them. So we can have this one, this could be time, this could be velocity, and we can compare the acceleration by looking at the gradients of two of these. Or it could be a distribution graph, and we can compare the distribution based on where the peak of the graph would be. To calculate the median, it is the middle number. So if we look at our numbers, you always have to be in order for this. Work in from the outside, we can see the median is 9. The mode is the most common number. And for that, you can see 11 turns up 3 times. The mean is the values added together and then divided by the number of values. So if I add all the values up, I get 128. There are 15 values. 15 divided by 128 is 8.53 reoccurring. The range is the highest number, which is 19, minus 1, which gives us 18. The modal class is worked out from a table, and it is the class with the most common numbering. So in this case, it will be this one here for above 10. There are 5 types of scatter graphs you need to be familiar with. The first one over here is showing no correlation. Then, because all the points are tightly packed, we have a strong positive correlation. Here the points aren't very tightly packed, so we have a weak positive correlation. Here again, the points are tightly packed, but they're going down, so that is a strong negative correlation. And then here we have a weak negative correlation. Now, using a pencil and a ruler, you can draw a line of best fit through these things. Please use pencil and ruler, not like this. You can draw a line of best fit for these things. And from the lines that you've drawn on your graph, you can extrapolate these lines forward into the future and make predictions about what is going to happen. I can describe the probability of an element from a table or a tree. So here I've drawn a table, I have some results, and I've got the number of times that each of these results occurred. To find out the probability of any particular result occurring, you need the number of times, that'd be the number of times it occurred, over the total. So here the total is 100. If I want to find the probability of a 3 occurring, that would be 19 over 100. A 5 would be 27 over 100, and so on. And you can use a tree in a similar or the same way, looking at the number of times and dividing it by the total number of times it could have possibly happened. I can determine if an event is fair, random, or equally likely. So in an exam question, they might say something like a fair die is thrown. This way you can assume that each event is equally likely. Or if it's a weighted die, they should tell you how it is weighted. Alternatively, they might expect you to be able to work it out from a table. Now, if you've got a very low number of total times, we can say that's a low n number. It's going to be very hard for you to tell, but if you have the more results you have, the more times the dice or whatever's been thrown, we say that it's a higher n number and it's much more likely to even out. So these numbers here, if we threw this dice or spinner or counter 1,000 times, would be much more likely to even out if it was a fair spinner, but if it was a weighted one, then the weighted would show up more often the more times it was thrown. I can give a value out of 1 for the probability of an event. So if you go back to our first set of data, the probability of getting a 5 is 27 over 100. We can write that as a fraction, or we can write it as a decimal, so 0.27, and that is a value out of 100 to give the probability of an event. Now, all probabilities must equal 1, because when you throw a dice, you're going to get a number. Doesn't matter whether it's a fair dice, whether it's an even dice, whether it's a weighted dice, or whether it's a fixed dice. If you throw the dice, you are going to get a number, so all probabilities will add up to 1. You might be asked in an exam to combine sets of probabilities. So say we had a dice and a coin, and you'd have to work out all of the different combinations. So for this, you'd need to draw a table. So your dice, your coin, your dice would obviously have 1, 2, 3, 4, 5, 6 different ways of landing. 1, 2, 3, 4, 5, 6. Your coin would have 2 different ways of landing. So heads or tails. And then we have a total of 12 possibilities so that you can work out the individual probability of anything. So the chance of getting a 4 and a head is going to be 1 out of 12. Venn diagrams can look scary, but they are not that bad. You just need to get used to the way of naming things. So here in our little curvy brackets is a set of data, and I'm going to call that set A. An element, not the chemistry element, I'm afraid, is part of a set. So we can say that 4 is part of set A. The number of elements is going to be the n number. So we can have n of A, and in this case, n equals 6, because that's the number that I've gone up to. Each part of the set is a member. So we can say that 6 is a member of A, and then all items in the set are everything. So we use this symbol here to say everything in the set. Now, when we have our Venn diagram, we might be combining two sets of data. So here is a set of data A, and here is a set of data B. And if we want something that is in both sets of data, so in A and B, we can use this nomenclature, A and B. If we want something, A, B, that is in either A or B, we go A or B. And then if we want something that isn't in our set of data, so here is A, here is everything else, here is everything, that is called A everything else. So the bit outside our diagram is A everything else. The nomenclature here can make these a bit nasty, but it's still just probability. Still treat it like any other probability and you will be fine. Whenever you see a wordy question for probability, try drawing a tree. So here we have 2 dice being thrown. So first dice, second die. And I want to know the probability of getting an odd number or an even number. So odd, even, odd, even, odd, even. Now we know that there are going to be 6 total possibilities. 1, 2, 3, 4, 5, and 6, and that odd is going to be 1, 3, or 5, so that is 3 over 6, or a half, and even 2, 4, or 6 is also going to be 3 over 6, or a half. And we can put these on, half, 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 half. Now with these, whenever you see a probability question, what I want you to do is decide which path you are going to follow, and then highlight the path you are going to follow. So here I'm going to be getting 2 odds, and here I'm going to be getting 2 evens. Rolling a dice twice and looking at the results are both going to be independent events. So if we want to combine these, we look along our highlighted path here and see we've got half and half. So we have, I'll just write it down here, half and a half. And can be replaced with times. So this is a half times a half. And then we can do the same for even. So it is half and a half, giving us each having a probability of a quarter. Now, if we wanted to find out what was our chance of getting odd and odd, or even and even, we would then need to add these numbers, again giving us a half. So, and is times, odd is plus, or is plus, and is times, or is plus. In a bag, we have 4 red balls, 1, 2, 3, 4, and we have 2 blue balls. After a ball is taken, it is not replaced. What are the chances you pick 2 balls of the same colour? So again, we're going to draw a tree to work this out. This is your first pick. Here is your second pick, and we're going to go red, blue, red, blue, red, blue. Now the important bit of information here is that they are not replaced. So we need to take that into account when we are drawing our probability tree. So the first bit of probability we put on there, red is going to be 4 out of a total of 6 balls. Blue is going to be 2 out of a total of 6 balls. After we have taken a ball out, the total is reduced by 1. So the total is now 5 balls in there. So all of these are going to be over 5. And this is the bit that people sometimes miss. So if I take a red ball out first of all, there are now only 3 red balls, but there are still 2 blue balls. If I take a blue ball out first of all, there's only 1 blue ball left, but there are still 4 red balls left. Going back, we're going to answer the question now, what are the chances we pick 2 balls the same colour? So we can either pick red and red, or we can pick blue and blue. Because your probability of picking your second ball is affected by what you picked in the first round, this is a set of dependent events. So red and then red is going to be 4 over 6, and, which is times 3 over 5. And then blue is going to be 2 over 6 and 1 over 5. Our probability of picking red and then red is 2 over 5. Our probability of picking blue and then blue is 1 over 15. If we add those two together, we will get a total probability of picking red and red or blue and blue of 7 over 15.
Ouch! This is why in some videos I have unexplained scratches.